plus 1. If we evaluate the numerator, we are going to have 3 over 2 minus 1 over 1 to fraction. Then we take the LCM, we are going to have 2. 2 in 2, 1. 1 times 3, 3. 1 in 2, 2. 2 times 1, we have minus 2. Over the denominator, which has 3 over 2 plus 1 over 1. We can also take the LCM of this, which is 2. 2 in this 2 times this 3 plus 2. 2 times this 2. So the numerator, therefore the numerator will give us 1 over 2. The denominator will give us 5 over 2. Then we can rewrite this as 1 over 2 divided by 5 over 2. And if you change this to multiplication, we have 1 over 2 times 2 over 5. Then 2 can cancel this, then we have 1 over 5. So that is the answer to question number 2. Then question number 3. This one is a unique question because it's a WAEC question. It's one of the WAEC questions. Here we have given x over y is equal to 2 over 7. Evaluate 7x plus y over x minus 1 over 7y. Here we still imbibe the same method or employ the same method we use in question 2, where we divide each term by y, since we've been given x over y, the value for x over y. So in doing so, we have 7x over y plus y divided by y, 1, over x over y minus 1 over 7. Then since we have this, so we can evaluate this, and we have 7 into x over y is 2 over 7 plus 1 over 2 over 7 minus 1 over 7. 7 here 1, 7 here 1. So we have 2 plus 1, that is the numerator. Then the denominator will have LCM, which is 7. 7 is 7, 1. 1 times this 2. Minus 7 is 7, 1. 1 times this 1. So automatically we are going to have 3 over 2 minus 1, 1 over 7. So we can resolve this as 3 divided by 1 over 7. Then if we do this further, we have 3 times 7 over 1. 7 times 3, 21 over 1. And that gives us 21. Equation with fraction. What makes this different from others is that this one, when we call it an equation, that means we have equal sign, where we are going to separate the constant term from the term that has variable. Typical example of questions designed for equation with fraction is shown in figure 1.4a, which is solve the equation. You have this. So this is a typical example of what I am talking about. So here you have 1 over 3a minus 1 equal to 2 over a plus 1 minus 3 over 8. So the first thing we do here is to separate the terms and collect like terms. So by so doing, I can decide to say I have 1 over 3a minus 1 equal to 2 over a plus 1 minus 3 over 8. To make it easier, let me transfer my constant to the other side and bring this one in. So by so doing, I'll have 3 over 8 minus 3 over 8. When it comes, it becomes plus 3 over 8. And this one will be 2 into a plus 1. Then this whole one becomes minus 1 over 3a minus 1. The LCM, I look for the LCM, that is the next thing. So we have 8 into a plus 1, 3a minus 1. This is the LCM. So here, I will now use the LCM to multiply each term of the equation. So I'll come here and say this times this. I'll have 8 into a plus 1, 3a minus 1 multiplied by 3 over 8 on this side, equal to 8 into a plus 1, 3a minus 1, I multiply by 2 over a plus 1 on this side. Then I will have minus, there is a minus here, and we must be careful with the minus so that it will not affect our result. So here we have minus 8, a plus 1, 3a minus 1 into 3a minus 1. Into so this will definitely be, if you multiply this by this, we have this 8 into a plus minus 8 into a plus 1, 3a minus 1 multiplied by this, automatically you have times 1 over 3a minus 1. That's what we're going to have. Sorry for that. Then here we have this 8 can cancel this 8. Then we have 3 into a plus 1, 3a minus 1. Then this one can cancel this. 2 times 8, we have 16 into 3a minus 1. Then this can cancel this. Then we have minus 8 into a plus 1. So here, we can open this up. We have 3a plus 3 into 3a minus 1. Then this becomes 16 into 3a minus 1 minus 8 into a plus 1. So if I open this, I have 9a squared minus 3a plus 9a minus 3. Then this one becomes 48a minus 16. Then this one becomes minus 8 minus minus 8a minus 8. So the next thing to do now is to collect like terms. So if I want to collect like terms, let me simplify this. I have 9a squared plus 6a minus 3. Then I have 48a minus 8a. We have 48a minus 8a minus 16 minus 8. Then this, I have 9a squared plus 6a minus 3a, and this one gives me 40a minus 24 minus 24. So here, the next thing to do is to collect like terms. And by collecting like terms, I will have 9a squared plus 6a minus 40a equals to minus 24 plus 3. And this one will give me 90a squared minus 34a. So at this point we have 9a squared minus 34a minus 21. Then this is looking more or less like a quadratic equation. So I bring this to the other side. I have 9a squared minus 34a plus 21 equal to 0. Here, this is now a quadratic equation. I use this to multiply this. Then I will have 9, 18. So that will be plus 189a squared. So I want to check for the factors of this 189a squared such that when they are multiplied, those two factors are multiplied, they will give me this. And when they are added or subtracted, they will give me this. And there is no other way of doing it rather than to reduce this bigger number, which is 189. 3 can go in 189. I have 6, 3. 3 here, 21. 3 here, 7. Then 7, 1. Now, if you combine these 3, I will have 3 times 3, 9. 9 times 3, 27. So I have 27 and 7 as one of the factors. Instead of wasting time, I have 27 and 7 as one of the factors. I want to check, knowing fully whether I suspect these two numbers, two factors. Now, if I have minus 27 minus 7, that will give me minus 34. Then if I multiply this by this, automatically I'll get plus 189. So definitely minus 27 and minus 7 should be a factor of this that will suit this model. And in doing so, all I just need to do, since a is the dominant variable here, I will just add a to it. So anywhere I see minus 34a, I will replace it with minus 27a minus 7a. So in doing so, I will rewrite this quadratic equation that I have, which is 9a squared minus 27a minus 7a plus 21 equal to 0. Then, what is common to this? I can dissect this way. What is common to this? 9 and a. Then I'll have a minus 3. On this side, what is common? Minus 7 is common, a minus 3. So I'll have what is common here, a minus 3, I factorize it out, then I'll have 9a minus 7 equal to 0. And when you arrive at this point, you can say a minus 3 is equal to 0 or 9a minus